Madam will be joining in 5 minutes only. Please wait for. Good afternoon, ma'am. Good afternoon, ma'am. Oh, no voice.
Okay, so can I start?
Yes, ma'am.
Good afternoon.
Good
Hello.
afternoon.
Yeah, can I start?
Yes, ma'am. Yes, ma'am. You can.
Okay, please. Just give me 2 seconds. Okay, good afternoon, students. So today, students, because we were doing about generative AI, and one of the very big aspect of AI is computer vision. And there are a lot of patent which is obtained by a lot of companies. For example, I know, one of the IT guy who is working in TCS, he has 12 patent in computer vision. So we're going to talk about computer vision and NLP, and we will see some example that how the computer vision is one of the most sought after career today for the developers, especially the AI specialist. And there are a lot of applications which are made on the basis of computer vision, and also the computer vision is widely used in industry. So we'll see those example also, and we'll understand how the computer vision work. Okay. So let me share my screen with you. Just give me a few seconds. Okay. So can you all see the screen?
Yes, ma'am.
Okay, fine. So today, the session will be on computer vision, and the computer vision, one of the domain, of AI. And as I was telling you, that there is a lot of scope in this particular domain of AI, and there are a lot of people from India, a lot of professionals from India who are developing a lot of solutions and application based on computer vision. So we are going to talk about that today. So computer vision, and also we are going to focus on something called natural language processing. So we'll start with natural language processing and slowly go over to the computer vision. So we all know that the human language is very complex. And when we see the data which comes to the computer, whether it's a text data or it's an audio data, or it may be a video in which we have audios, uh, 20% of these data which is collected in our system or by the servers or by any of the application programs are structured. Rest of the data are unstructured. Whether you talk about social media like Twitter, WhatsApp, or it's an Instagram, or it's any other YouTube or audio podcast or anything like that. All these data, huge tons of data which comes to the AI for processing, or it can be in the form of any other kinds of format. These all data, as I said, out of these entire data, 20% of the data is structured, rest 80% is unstructured. And how the question comes in our mind that how do we get insight from this data? Imagine you're getting in medical industry a lot of image data in the form of CT scan, in the form of MRI, chest X-ray, in the form of so many things, ECG. All these image data need to be understood by the computer to come up with some kind of interpretation or some kind of conclusion. So how do you derive the insight from these 80% unstructured data, which can be in any format, text, image, or it can be an audio or video format? So here comes the the one of the feature or the domain of AI, which is called NLP, natural language processing, which is again a domain of AI, or maybe it's a part of computer science, which try to deal with interpretation of these data in the form of human language. And I'm not talking about when I say human language, students, I don't say it is English. It can be any regional language in India. It can be any foreign language. It can be in any form, or it may be in the form of a shortcut language which you people do, or lingos, or anything, whatever you use it on social media. So when the companies like Amazon, Flipkart, or big companies, eBay, and all these big companies, and even other IT companies, when they have to do the text mining or sentiment analysis from the social networking site where the customers go and post their view, they may give a very negative view, they may give a positive view, they may give a neutral view about anything which they have bought, they may share their experience, and the companies are looking for this data. I'm just giving one example. And when the company pull this data from the social networking site about them, let's say if I go to Instagram and I say something about Amazon, and I use the word Amazon, immediately the system, this application trigger that, and it get mine those comment from my account to them, and that data is collected. And after it is collected, they basically try to analyze and interpret whether the comment is positive, negative, or it's neutral using the NLP mechanism. And with this, they try to analyze and then give a response. So every e-commerce company, these companies natural language processing, which enable this particular system or application to interpret anything from the spoken words or written words, or it can be in the form of audio or any other kind. It try to make out sense from that, just like a human being. It try to mimic those kinds of interpretation. So when something is told, for example, when you are a baby and when you are 1 year or 2 year old, you might be blabbering so many things. You may call something else, right? And that time your parents will understand, because they have been with you, and with experience they know that though maybe the what you are asking or what you're pointing out is not literally the name of that particular object, but they understand because they've been with you. But for computer, it is not easy for them to interpret something like that. Though till now this kind of a system or the intelligent system is not built, that is a super intelligent system, then it can make out from anything which literally doesn't mean anything, like us. But the what I try to say here is that the ability of the computer to interpret human language in any form and analyze and interpret it and derive the meaning out of it and respond to it. So one example I gave you on that. So NLP is one of the domain of artificial intelligence, which is also it is not only the people who are expertised in AI are actually doing a research or doing a study in NLP. Even the computer science students who are not specializing in AI today are taught on NLP. So maybe you might have heard about it, or your teacher might have thought about it. Okay, so I'm going to talk about that today. So it all deals with human language in any form. It tried to do something called text analytics or text mining. All these kinds of things is called NLP. Okay, so let's go to the other one. So one more thing which is very challenging and revolutionary in artificial intelligence students are that AI cannot speak, AI cannot write, AI cannot listen and understand human language. I'm sorry, I'm saying AI. I'm saying normal machine, traditional machines can't speak, can't write, can't listen, or can't understand human language. So can we do this? Can we build this ability into computer? Can do that. So the natural language processing is the way how we process the language, how we understand, right? For example, I remember a scene from a movie called PK, Amir Khan movie, where he was an alien. And there was a scene with Anushka Sharma. And basically, he was actually expressing, and he was telling that how human language is so strange. He said that one particular word can mean different meaning or with expression. So when you express a word, it can mean literally something else. So he gave example of acha, word acha, which means good in English. So if you say acha in different way, it may mean different things. It may mean you are surprised. It may mean that, okay, it's very good. Or it may mean that, okay, fine, it is. So the way he expressed, I'm sorry, I could have shown you that clip, but that particular clip, if you want, you can just imagine if you have seen that movie. I think most of you might have seen that movie. So that scene in the jail where Anushka Sharma is interacting and the person said, I have learned or transferred the entire Bhojpuri language from a girl by just holding her hand. And how he realized that the human language is so complex and so weird that one word can literally mean different thing if you add expression to it, then how do you feel that a computer can understand the same way the human being can understand that? Because we have that natural language, we have that ability which is built into that. So if we build that ability into computers using AI, it's called NLP, natural language processing. So NLP is a form of AI that extract the meaning from human language to make decision or interpretation based on the information, just like the way human being will do. Okay, it will help them to understand that. So this technology is still evolving, students. There are already many incredible way where the natural language processing is used today. We will look at some example today. So we will highlight some of the everyday use of natural language processing, and I will be giving you the 5 very common example of how NLP is transforming business today. So NLP is the ability of a computer program to understand human language as it is spoken, written. So it is also a component of AI, as I said. So NLP has started 50 years back, when people thought that when we are trying to inbuild AI into computers, why not build one of the or mimic one of the intelligence feature or characteristic of human being, that is about how to understand human spoken and written language. So let us look into some of the real world application in many fields. It can be in medical, it can be in search engine, it can be anywhere. Okay, so let us see that. Okay, so when I'm talking about NLP, as I told you that NLP is still an area of research, and it is also an area of computer science, which focus on language processing. It can be a English language, it can be a German, it can be any language. So what do we mean by processing? Well, we are taking this language and converting them into a number that computer understand. All of you are computer students. I know that you will understand how any particular language is translated or compiled into a machine language. So that's what I'm talking about. So computer can perform several tasks using NLP, like text classification, text generations, your text creations. All those can be done with the help of, or answering a query like Alexa doing it. Okay, so there is also a word which is existing with NLP now, and which is a field of research. Not much of work is done in that, which is called mathematical linguistic. Okay, linguistic is becoming a very big thing now in schools. Small kids are also taught on that. So NLP is just like a kind of a child who's trying to acquire a language. Okay, for example, when you have a small baby, and if parents are working, like one of my friend or colleague, when I was working in ITC Infotech, at that time both parents were working, and the child was with a maid, and they were from north, they were North Indian, and the child was with a maid who was speaking Malayalam, and she didn't know how to speak in Hindi. And entire time, so the child started speaking in Malayalam. But because the parents were speaking with the child in Hindi, he also was speaking in Hindi. So anytime my colleague was telling me that if I have to communicate anything to my maid, I had to take help of my neighbor. Now my child was helping me. I was telling my child, okay, tell this to the lady, and he will tell in Malayalam. And the child was just 4 years or 4 or 5 years old. So that is how the children intelligence, that is the reason why we say that the small kid can acquire the language faster than the human main adult. The reason, one psychological reason, is that when we grow old, we start having a perception about certain language, and we have a wish to learn or not. But a small kid will just pick up the language by hearing it. It's so, they are so sharp, the brain is so sharp. So it is just like a child who can acquire many language, as it is very easy for a child and it is very hard for an adult learner. So similarly, the scientist who was attempting to model the NLP are attempting to build a natural language processing system based on child learning, children, not on adult learning system. Okay, so that is one thing. So this task are little hard, because Turing could actually, Turing test, if you don't remember, or maybe you people will know about Turing test. I've also discussed many times that Turing test, test the system ultimately on its intelligence level, which it is exhibiting. So the Turing test has to understand whether the machine is able to do the fluent conversation in natural language, okay, or not. Okay, so let us see the computer, researcher Yoav Goldberg, who has done a lot of work in actually NLP, also said that human language is highly ambiguous and it is ever changing and evolving. Now, if you see in our India itself, we used to speak Hindi in Awadhi. Then people started speaking in certain part of India. The Hindi is spoken in the form of Urdu, like Lucknow and that side. Then in Hyderabad, if you see, the Hindi is different. If you see in Maharashtra, the Hindi is different. So every part of India, you may find that the people pronunciation, their accent is different. Similarly, English also have the same feature. If you hear Chinese people speaking English, you won't understand. Maybe most of the time it is said that Indian people have a good English speaking skill because we were under the British for so many years, more than 100 years. So that's the reason we could speak a proper British English. And if you see the US English, their accent is totally different from a British or UK English. So the people at this moment, when you are speaking to a, let's say, to a smart speaker like Alexa or any smart voice search, the way we speak English and the way the English and Hindi has evolved, we use a lot of shortcut, we use a lot of words which has different kind of meaning. Okay, that day, just for a fun, I was watching some TV serial where the Salman Khan was there, and he was, I think it was Big Boss, and Sara Ali Khan came, and he said, sir, you are goat. And he said, what are you saying? How dare you say like that to me? I'm so senior to you, I'm just your father's age, and you are calling me goat. He said, no sir, it is like greatest of all the time. And he said, oh, does that mean this? So people, your generation has certain kinds of your language is little slightly different from the way we used to speak, or maybe our older generation used to speak. So that is how the people language complexity is changing over the time. So it is very, very important for the computer to understand the language, the way it is spoken, the accent, how it is used, how it is expressed, and it has to perceive the meaning and interpret the meaning of those words which are spoken in a different way or which are spoken in different accent. So, like, while we humans are great user of language, we are also very poor at formally understanding, describing the rule that governs a language, right? Nobody follows that. So if we build NLP on the rules of English grammar or literature or linguistic, then it is very hard for NLP to pick up those and understand those statement or maybe those comments on the social networking site, which has a lot of shortcuts, which have lot of words which is spoken in different way but means something else. Just like I gave you some example now here. So that is the reason the NLP is still evolving. It is trying to understand, it is not purely based on the rules which are governed by the language rules. Okay, so this is how this thing is there happening. So let's look at some of the tasks which is involved in natural language processing. For example, in sentence classification. So when we are doing a classification, we are in the school, if you remember, they might tell you that the part of the speeches for each word, whether it is verb, noun, and you have to classify that. So how does a NLP also go through that? I will tell you in the further slide. So another thing about how the companies are using NLP is sentiment analysis, which I just told you. Finding the reviews, whether the review is positive or is it negative or neutral. It is very difficult nowadays to find out. You may mean sarcastically it is too good. It is too good to be. Some offer is given by the company, and I've read in one of the example where the customer saying it is too good to be true. and they made a memes, or they put a, what we call emoji, which was actually crying. That means it is fake. And now the NLP, the bot immediately replied, "Thank you for your appreciation." And the person gave a question mark. That means I didn't say I didn't appreciate. I was sarcastically telling it is too good to be true, the offer. So that is how the sentiment analysis try to determine from your review whether it is positive, negative, or neutral. So this has to be, now for that the computer need to be trained. The computer need to be trained with lot and lots of data, which make the computer classify each word, sentence, come out with the context, how it is sent, try to understand the expression in the sentence, like this. One more example is financial institutions. The financial institution or NBFC, like non-banking financial corporation, they are always interested in this application for new customers. If a company want to set up a new account, there are several checks that they must be made. If a company trade in only lows, suppose the bank is trading in low risk country, and it is their main business activity is considered as low risk. Okay, so their onboarding process can be fast track. Onboarding of the customer on the site using the form to fill can be fast track by determining what part are names, locations, organization. So they have to classify, because suppose, for example, JP Morgan Chase, if they use the same form what they are using and use NLP to understand that in US to India, the names are different. You don't know which is the first name and last name. And if you ask to write the entire name, at least in Indian NLP, if you're using NLP, you will understand, okay, this is a last name, this is the first name. But India, suppose in most of the part of the South also, you have, suppose in Andhra Pradesh or in certain places, I've seen the names are very big, because they add the name of their ancestors also and the family name also. So how do you understand that? So that is where the task is taken by the NLP to auto generate and segment and do the segmentation. Grammatically, if incorrect sentences are there, most of the time we don't write correct English or speak correct English. It can translate that, understand that, and give you the response immediately. It won't say that we don't understand, speak correctly. Okay. So the simple function of NLP is to facilitate understanding of human language, as simple as that. And there are some examples which I'm going to highlight to show you now the application. So the first one is called the social media monitoring. Okay. So how does NLP is used in social media monitoring by companies, which I just told you? NLP based tools like Buffer can help business to monitor social media channel for mention of their brand and alert them when the customer is talking about those brands. Just now I told you about Amazon. Okay. Then the next example is text classification. Okay. So the text classification, where the text input can be sorted by topic, by tone, by context. And these applications aid in filtering spam mail, for example, in Gmail and all, it is used. Language, for example, when you're trying to write something now in the Gmail, it try to give you suggestion and try to fill you depending on what word comes next, like generative AI. So it is used now in Gmail. You write something and you don't finish, it will try to give you the graded word that you can finish with this. So that's how it's called. In a way, this is a AI tool. Then the Google auto complete feature. If you go into the search engine, you can see the Google auto complete feature. Even in e-commerce search engine also, suppose you are writing red sports shoes from, it will give you the name of the companies. So if you are writing best MBA college, it will give you the option. If you are writing best SUV under, and it will give you the different option, under 10 to 15 lakhs, under 15 to 20 lakhs, in Bangalore, road price, all those kinds of option it will try to complete. That's also using NLP, because from the word and the context and tonality, it understand what can be how can they complete, and they can help you narrow down your search. Then the sentiment analysis, which I just told you, that NLP is used in measuring the customer opinion, monitoring a company reputation, and also understanding whether customers are happy with the product or services or not. And this is a very great help for the company because it helps them in determining if the customer has a positive, negative, or neutral view towards their brand. Then the next one is also called, the other one is also called the, the target advertisement, which you see online. So I'm sorry that slide is not showing here. So the target advertisement is basically to the user-based online activity. So when you're browsing and looking for some tickets or something like that, there's an online, the companies will set web crawlers and understand what you are looking at and try to follow you up. So NLP try to target, give you target advertisement in social sites or any other site, depending on the technique called matching, keyword matching. Okay. Then email categorization. Gmail uses NLP to group email, what you receive. So we have seen the email that are categorized into 3 tabs. If you notice into your Gmail, you have primary tab, social and promotion tab. So all the personal mail go to the primary tab. All the notification from social media platform will go into social tab. And all the newsletters from the company that user has signed up will go into promotional tab. So it is not totally perfect, you can say that, but NLP help it to identify and evaluate the content of each mail. So the content of the, based on the content, they can categorize them into primary, social, or promotional mail. Then automatic summarization. So let me see if it comes. No, it's not. Okay. So automatic summarization also happen nowadays with the NLP. So autocorrect option in Gmail or in Word documents. Now GPT is integrated into your new version in 2021 version of MS Office. Out of 2019 version of MS Office, you have GPT integrated. So you can just complete a sentence. You can write a short essay, but just summarizing it. You can summarize the entire content of 5-6 pages into 1 page or 1 paragraph. So there are a lot of tools in that. Like, for example, you can go to Meaning Cloud, you can go to ML Analyzer. Early prediction of disease. NLP has enabled the recognition and prediction of disease based on electronic health record. So whenever a customer nowadays, every big hospitals like Vikram Hospital, your Manipal, Apollo, all these hospitals keep your health record. So all your tests are stored. There are a lot of apps also like M-File. A lot of health apps are there where you, when you go to and do certain diagnostic test, all your reports come and get stored there. And from your report, if you see, you get all kind of notification. If you are diabetic or if you have high cholesterol, they send you notification or target ad on that. Apart from that, even these kinds of health record which are maintained by hospitals, they use NLP to analyze these records, and also sometimes the patient's speech is also recorded. If you remember one of the session, I have shown you a demo of one of the particular app on AI, where the AI can, from the tone of the person, can analyze whether the other person, whether the person is getting a heart attack or not. So it has gone to that particular stage. Even in mental health, the patient tone, the kind of the way the patient is speaking, how many pause the patient is paying, depending on, even NIMHANS is doing that. They record the patient, speech when the patient is having a counseling session with the doctor, and after that they play that and put it into the application, and NLP try to understand whether the person is going to suffer from is suffering from depression or schizophrenia or something like that. The Google Translator is also one of the big example how they use NLP to translate anything in one language into the other language. Okay. Now let's look into some more application of NLP and some of the natural language processing applications, and understand also how they decrease our workload and help us in completing many time-taking tasks quickly and efficiently. So email filtering is one of the example. Email is the part of our day-to-day life. I just told you that primary, social, and various, even the spam filtering happens. Natural language processing is helping us in filtering the spam mail or the important mail and labeling the mail automatically. Label the mail. For example, if you are keeping labeling some of your email as important because it has come from us from your boss, it will next time when the boss sends a mail, automatically the label will come to that because it will recognize that these mails are important for you. Okay, so it's like that. Then language translator, just now I told you that we are in the world, living in a world where many languages, many cultures exist. Everyone understand all these languages, not possible. So the world is a global village now today because of technology, and we communicate with the other people. For example, if we have to do business in Japan, nowadays people take the translator. Initially we have to take our interpreter with us, and that human person will interface between that and this person. Today, if you have seen one of the speech I was seeing, where Narendra Modi was talking to Yugoslavia, prime minister or somebody, and I could see, initially I used to see that prime minister used to take a interpreter who will be helping to translate from Hindi to English, or maybe the language which the other person is understanding, and from that language to the other language which Narendra Modi can understand. But that day I saw in the TV that he was speaking normally in English, and the other person was speaking in his own language, and both of them were unable to understand. And I was really shocked. I thought Narendra Modi no Yugoslavia language, but later on I found that this was because there was an application which was prompting the whatever the person was speaking. So there was a mic. This mic was taking the input as the person, as these two people were speaking. The other person also was not able to understand English. So when Narendra Modi was speaking in English, his English was translated into Yugoslavia language by the natural language processing thing. So when he was speaking in the mic, the application was converting and showing every word which he has spoken in the language. And when that person was speaking, Narendra Modi could see that in English in his screen. So he was able to understand that. So that is how the NLP is helping us to translate the language with all kinds. Then smart assistant like Alexa, Siri, and all these devices, smart speakers. All these smart speakers are helping us, to talk to them in any language or in any way what we want, and they try to understand and respond to us in the same way. So all these are possible, students, because of NLP. So it helps the computer system understand our language by breaking up into parts of speech. Okay. And like I will come to that, like root, stemming. I have already told you in one of the sessions, but again, I will tell you that what are the different segmentation and stemming it does. So the document analysis also. Today, the companies, the financial companies, the contract, the MOU signed between the government and the companies basically use NLP application as document analyzer. So company, colleges, schools, all these people are taking the data from the, like you're feeding the data into the forms, and these data which is stored and maintained, are researched by using NLP. And NLP, what it does, it not only it search a keyword, but also it categorize it according to the instruction and save us. So for example, the document which comes, it will look for certain keywords into that, and so try to pick up those words and try to understand whether those words should be there or not. Like if you're making a contract, there should be certain words or certain law which should be there. So the NLP help in analyzing those documents and look for those keywords which are present in a right context or not, and try to tell you whether the document are correct or not. So you don't have to go through the document, which normally we don't do that. Online searches. So online search is something which is very important for all of us, because that's a source of information for most of us. So one of the most extensive information source is the internet. So we type what we want to search on the Google or maybe Bing, and we get everything what we want. So from anything to everything, we can get to know about it. So the answer is that how does it understand the word which you are writing in the search engine, and how does it provide the right information so that you don't it will narrow down your search and you don't waste a lot of time. So today, the Google search, Bing search, they all are using basically NLP to make the search engine understand what is asked and what does it literally mean. Right? Initially, it was a traditional meaning was take a word, match it with the word in the website and give you that. If it is there in the title or if the word is present in the meta tag, and it will give you that. So today it is not like that. It will also tell you, for example, you're writing something, it will also tell you the word which you are typing. It's in certain links, those words are, certain things are missing from there. So that is one thing which we should be knowing about that. Then the other example is predictive test. Online predict what you want to type. So we are typing something on the smartphone, the letter on the screen, the keyboard give you suggestions, the words. And today in the keyboard also, you can just go ahead and you can just make us fast typing. Okay, I don't know what it is said, but then you can go to the keyboard of your smart screen and you can just do like this and it will understand what word you mean. And it will type that particular word for you. Predicting the next text in email or in search engine is also the example of NLP today. Automatic summarization, I just told you that it can summarize the entire document into something. It will also interpretate that into a simple language, understand also the emotion hidden behind in the information. So these are something. Sentiment analysis, already I told you. Chatbots, today chatbots are widely used by bank, by shopping sites, for booking ticket, for customer services. So you don't have to wait for a long time to get a person answering your call. Chatbot reply to you instantly, accurately. So NLP give this chatbot the conversational capabilities. It helps them to respond to you the way a human customer service agent will respond, okay, with expression which you want. So chatbot helps in places where human power is less, and they can make the service available to you around the clock. So chatbot operating on NLP can be, or is also nowadays using emotional intelligence to understand the customer emotional sentiment and respond to them. For example, a customer shouting, the person, the chatbot is not a human being to understand. If, and they'll say, no, I want to talk to a machine. I don't want to talk to a machine. I want to talk to a human being, because they believe that human being can respond to their emotion the way it is. Because when a human being talk to a person who's agitated and say, I am so angry with you, who are you, I don't want to talk, this and that, the person will respond in the same way, I'm so sorry to hear, but let me help you, sir, let me understand what happened with you. So there is a sympathy, there is an empathy in that tone, and try to calm down that person. The same thing is inbuilt into NLP, by NLP into chatbots, to understand the emotion sentiment and respond to the customer the way the human being may respond. I told you about social media monitoring already, that how the social media monitoring is happening nowadays, where if a customer is sharing his like, dislike experience and tell about something, about mention a brand to some individual, immediately the NLP can mine those kinds of sentence and categorize whether it is good, bad, it is positive, negative, or it is a neutral thing. Okay. So this is the one which I gave you example, email. Then the sentiment analysis, and also what you want to understand, you can just translate that. So all kind of translation which can happen. Now let's look into the component of NLP. When we are talking about NLP, students, along with the technology, how to build this NLP system, you also have to understand the component in the way how it functions. So there are the following two components of NLP, which I'm going to tell you. The step one is sentence segmentation. Sentence segmentation is the first step for building the NLP pipeline. So what happens, if you see in the slide, there is a paragraph which is divided into separate sentences. Example, consider the following paragraph here, which which you can just go ahead and read. And this paragraph, if you can see, there are certain words which are highlighted, like stuck, nightmare, classic, classy, legend, prove, chop, drive, show, done. Some are light pink, some are dark pink in color. Okay. The dark pink in color are the word which is put into dark, highlighted, because these words are important word. Okay. And this is the important word and the key word of that. So even if you don't have a time, for example, when we are, you may, when the papers are checked and when you are required to check certain things, and you may not read the entire line by line, word by word. You will look for certain word and will understand from the sentence 2 3 word what they are trying to say. So similarly, the NLP also does. They pick up those words which highlight the meaning and summarize the meaning of the entire paragraph, which is called important word. So that is the first one, is called the sentence segmentation in this form. And the second one is called the word tokenization. Okay. Word tokenization is used to break up the sentence into several words, separate word and tokens. Okay. Like, for example, here, if you see here, one example here you can see. So you can see a lot of words are here. Word brace, learning, learned, deep. Then deep is divided into DEEP. This is called, stemming of the word. Then learned is learn is the word which is stem word, and ED is the word which is added to it. Here also learn is a stem word. Here also learn. So there's a common word which is learning in these words called learning, learned, and deep learning. Then learning is there and all these kinds. So they take out this tokenization where they try to take out. So if the similar word which has the same stem word, like I have shown you in the slide, like for example, if you have corporate training, summer training, online training, winter training, they will pick up the word training. That is a stem. So that is the main word which they can take out from there. After taking out those word, or which is called the tokenization, after tokenization, the third process called stemming. Stemming is used to normalize the word into base form or root form. For example, celebrate, celebrated, or celebrating. All these words are originating from a one word called celebrate. Similarly, playing, plays, and played, the root word is play. Okay, so that is a root word, or it is called stemming. So similarly, like one more example, intelligence, intelligent, gently, sorry, all these words are originated with a single root word, intelligent. So the intelligent is the stemming word. The fourth step is called lemmatization. Okay. So this is stemming, where they try. So you can see here, all these words stem into the root word. All these words stem into the root word. So this lemmatizer, let me see how the lemmatizer is going to work. Okay, this is stop word. So lemmatization is very similar to stemming. So most of the time people get confused whether this is stemming or this is lemmatization. See, why I'm telling you all these steps is because when you're building NLP, any system with NLP, you need to know about the the structure of NLP, and that's the reason why you need to know what is this. So the main difference between the stemming and lemmatization is that lemmatization is quite similar to stemming, but it is used to group different inflected form of the word called lemma. The main difference between stemming and lemmatization is that it produces the root word which has a meaning. Same thing. In lemmatization, the word intelligence, intelligent, and intelligently has a root word called intelligent, whereas in stemmation, the same intelligence, intelligent, and intelligently will have a root word called intelligent without T. That's the root word. Okay, so this is the difference. Because lemmatization will come up with a root word which has a meaning. Stemmation will come up with a root word which may not have a literally any meaning. So that's the difference between this and this. Okay. The next fifth one is called identifying stop words. Okay. So in English, there are a lot of words that appear very frequently, like is, and, be, a. NLP pipeline will flag those words as stop word. Stop word, I'm not meaning here where the sentence stops. Those are punctuation marks. So I'm not talking about punctuation, students. I'm talking about those words which will indicate that this is a word where it might stop. The stop word may be filtered out before doing any statistical analysis. So you can see that. So an example like he is a good boy. So when you are building a rock band search engine, you ignore the word the. Okay, so he is an a is the stop word here. Okay, that's how it works. The sixth step in this is called the. So this is how it does. Okay, you can see here. The sixth step is called dependency parsing. Dependency parsing is used to find that how all the words in the sentence are related to each other. How the noun is related to verb, how verb is related to adjective, all those kinds of things. Okay, so you can see here how these words are related to each other, that has been characterized. Then the last seventh step is called pause tag, POS tag. Okay, so pause tag, I'll just tell you how it is. So when you're talking about the pause tag is basically a phenomena where the pause stands for part of speech. So what it does, after the words are separated and segmented, it will put a tag to it saying whether the word is noun, verb, adverb, or adjective. And it indicates how a word functions with its meaning, with grammar within the sentence, or with the context. Example, Google something on the internet. For example, you write like that. In the above example, Google is used as verb, though it is a noun because it's the name of a company. But when we say Google it now, that means search it. So literally NLP should have to understand this. Okay. So this is how the NLP uses all these kinds of mechanism. There are other also. I must suggest that student take it seriously. You can build your career well into NLP and computer vision. For that, you have to know how the NLP work theoretically. Then only once you understand the theoretical concept, once the concept is clear, then you can go ahead and you can make an application. Without the concept clearance, you can't do anything. You can't go ahead and you can't understand how it is applied. Okay, so I'm going to take you through a artificial intelligence technology area to come up with something where we can build a software and we can train a data with a lot of numbers and images. So I'm going to take you here. So what I'm going to do is I'm going to take you to a site where you can understand how to make certain, how does before going to a computer vision, because I'm going to start the computer vision. Before that, we have to understand, students, that how a particular system understand an image. When you show an image to for example, it's a driverless car. And when a driverless car see a animal, or if it is see a particular object in front of the car, how does it recognize that whether the object is a car, it's a non-living object, or it's an animal? So the image which is accepted as an input by the camera, and also the sensor which takes the input in the form of certain distance it is sensing, all these input, I'm especially talking about the image input. So the camera which record an image of the animal, or maybe an image of a rain falling or a water falling, how does it classify whether it is this object is a animal, or if this object is a rain falling, or it's a stone, or it's a tree, or it's a block in front of them to stop the car, or something like that, or a barricade? Okay, so this happens because the input which is received, the image which is received, goes to the AI system, where it has a computer vision ability to understand and classify that particular object based on the data which is fed into computer. When the data, huge data is fed. So for example, if it is a dog, so there's a lot of dog pictures which are fed. There's a lot of cow picture which is fed. They won't feed a picture of a what you call a fish in the computer system which is used in driverless car, because they know the fish won't come unless and until in exceptional rare cases. So they will put the picture of, in aeroplane they will put the pictures of birds, because the dog can't come on the sky and fly. So they will put the pictures of most commonly occurring animals on the roads, dogs, cat, the cow, especially in India. So they'll put those pictures and different kinds of cows data. So what happens when they take the picture of, suppose there's a cow sitting, and it takes the picture and it goes into the computer system where it is trained to identify the cow, whatever way the cow looks like, but it will try to identify. But most of the time it is not so accurate. In the super intelligence case, it is very accurate. So let us see some examples. So I will go to a site and show you that how it works with, just give me a few seconds. I'll share this site with you. Okay, so I'm going to take you to a site, students, where we're going to observe how the computer vision basically work in the background. Okay. So it's a application of AI, which is called of Google, called Quick Draw. Just a minute. Okay, so it's called Quick Draw with dot with google.com. So you can go to the site, and what you can do is you can log in with your Gmail account, and I'm going to just draw something, and I will see that whether the computer recognizes this or not. Okay, so I'm going to draw a bathtub.
I see banana, or line, or hockey stick, or garden hose. I see water slide, or hot dog, or hot tub.
I just tried to draw a bathtub because
Sorry, I couldn't get it.
So now it's asking me to draw octagon. So I will try to do it. Let's see.
I see anvil, or squiggle, or zigzag, or cloud. I see apple, or gear, or shrub, or hand, or glove. I see foot.
So see that?
Sorry, I couldn't guess it.
So now I'm going to try this. So it gives me, I'm trying my best to do something.
I see moon, or zigzag, or squiggle, or cloud, or shark. I see scorpion, or rhinoceros. Oh, I know, it's octopus.
See, it has recognized, though, didn't I draw it properly? So now street light. So I'm going to draw that now.
I see line. I see green bean, or asparagus, or hockey stick. Oh, I know, it's street light.
Right? See, it's got it. So
I see line, or ocean, or garden hose, or river. I see hat, or roller coaster, or mustache, or the Great Wall of China. I see bridge, or water, or shoe, or squiggle, or boomerang. Sorry, I couldn't get it.
So now it's asking me to draw.
I see squiggle, or roller coaster, or camel. I see rhinoceros. I see bicep, or bear, or the Great Wall of China, or foam finger. Sorry, I couldn't guess it.
So see here, I have drawn these fingers, and out of that only 2 were recognized, and out of 6 figure 4 were not recognized. So let us see how it is doing it. Okay, so I'm just going to go to the picture which it has recognized, not recognized. So it has asked me to create I think a boat or something. Yeah, bathtub. So I'll just show you. So what has happened when I draw this picture? It has lot of data which is feeded into it, which will tell that how does a bath, see, what does it think the bathtub can look like this? These are all vague images, not the correct images, drawn images. That people, if they draw like something like this, if this photo resembles somewhere here, it should be a kind of a, it should be a, so what the figure I have drawn resemble like this. So this is one thing. Now I'm going to show you the picture which I have drawn well. Okay, so now you see this picture could be street light, could be a toothbrush or an axe also. But they have given, how does it know that this is a street light? Because they have the drawn picture approximately which can look like a street light like this. This is the data which is already fed. I've also now fed one data into it. And I'm feeding the data with all possible kind of a drawing, which can make it look little bit similar to street light. I hope students, you have understood now what I'm trying to tell you. This is one very, very big example of computer vision. And this is also an application where you can draw and computer will try to recognize from your drawing. See, recognizing from a picture is very easy because in your database, you can have variety of it. I will show you that also. I'll give you example of that also. So any questions so far? Okay, no question. Okay. So now I'm going to go further. Let me see the time. Okay, students. So I will take you to one more example of computer vision. And so I'm going to first go and log in into that. Give me some time. So I'm going to take you to Teachable Machine with Google. Okay. So students, I'm again in one of the platform of Google, which is a very good platform for classification of images. So I'm going to show you that. Just let me take you there. Okay, all can see now. So you can see here, this is an example of teachable machine. You can go to this particular site. I have shown in one example also earlier on this. So I'm going to make this particular, this is AI, a no-code AI platform, where I will have to feed the AI and train the AI with huge volumes of data. So I'm going to now take this. My business problem which I'm taking is that, let's assume that there is a tire manufacturing company and they want to do a quality check. They want to classify good tires and bad tires, because every manufacturing company, after doing a quality check randomly on their sample production, they find out that whichever unit doesn't suit the or doesn't match the quality should be rejected and should not go to the customer. Otherwise, they will lose customer. Losing customer means losing business. So now this tire manufacturing company also want to use a system where it will, whenever the tire comes after manufacturing, it will be analyzed, the image will go into the system and the image will pass or reject the tire as good or bad tire. So what I've done, I have gone to Kaggle, because see, AI will work perfectly if you feed AI with volumes of data and correct data. So what I did, I went to a site called Kaggle and I downloaded the pictures of good tires, which has the good tires, all kinds of good tires in different forms, different ways, different angle the tires pictures are taken. Let's assume the company, whenever the tire comes out and it takes a picture and keep in the database. And all these feed it into the computer to make it understand that these, if the tire looks somewhat similar to this, it's a good tire. Then they also take the pictures of all the rejected tires, which may have some deformation in the form, which may have certain things missing in that, or which may have D-shaped, which may have certain cracks on it, or it has some manufacturing defect. So they will take the pictures of all those tires with different in different angle, with different defects in that, and put them into a category and label it. See, these are label data. So I'm doing a supervised learning. You all know that by now that supervised learning basically help to analyze the data which are labeled. So I'm going to feed, I have downloaded all the pictures from a site, which is a public site of getting data, which can be a number data or a image data. So I've already collected and stored in my file. So I have this class. I can go and call it as good tire. And then I'm going to upload the sample image to train my AI. Okay. Give me a few seconds. So I'm going to go to okay. So I have all the tire picture here. I have huge volume of data which I downloaded of all good pictures of tires from all angles. I'm going to select all and I'm going to load all these pictures. It's going to take time because it's a huge data you can see here. It's taking time to download, to upload all the good pictures because the data is huge volume of data I've downloaded. So more picture you give, more varieties and volume of pictures, images you give, better the computer understand and able to classify. Similarly, you feed all these kinds of data, like I was telling you, driverless car, you feed the all kind of dog pictures, all kind of cow pictures in all positions, standing, sitting, in every kind, sound pictures of various kinds of sound which you can hear on the roads, all kinds of images, pictures which can appear on the ground, and classify that. Classify dogs and put all dogs picture. Classify cat, put all cat pictures. Classify cows, put all cat pictures. Label it. And when it captures, the camera captures a dog picture, it goes back to the data and try to match that picture with any of the data available because it is trained. It will immediately classify this is dog. Okay. Now the second classification of data I'm going to put is bad tires or defective tires, whatever you wish. Okay. I'm going to upload the pictures of all kinds of bad tires. Okay, that also I have. So I have all the pictures here, huge volume of pictures. I have selected all, and now I'm going to open and upload this picture. Again, it's going to take time. So all kinds of bad tires, defective tires, pictures from all angles are collected and maybe led by the company, and they may put it so that they may train the AI model properly and help them in classifying. Again, the beauty of AI is data. The perfect data, if you remember one of the case I was telling about, print of cheetah, footprint, the indigenous tracker can track, without looking, without knowing which animal footprint, they can tell which animal. Not only this, they can tell all the gender and where they are heading to. So these kinds of experience you have to build so that the computer know that if this kind of pictures or similar picture comes, then you are going to, they can classify it just like human being. Now what I'm going to do is I'm going to train the model. So because it's huge data, it will take time to train. It is going to now understand. See, we have 530 images of bad tires. And there also we have many images. It's going to train the data on the good tires. How does it look? And now it is getting to understand how the bad tires sample data will look. Then what I'll do is I will take a picture which is not from this data. I'll take any picture, one picture of a good tire, which is not in the data, which I have uploaded. And let me see whether the computer recognize it or not. I think there's some problem. Let's see. Yes, it's going now. See, it is going to take time because the data is huge. So it's going to train the data now. And after that, I'm going to feed with some data. Anytime I feed with the data, it is going to classify the data. Okay, so you can see now it's almost ready. So each and every picture from good and bad tire image, like 491 image of good sample of good tires and sample of bad tires I have taken. I can add many classes like that. Okay. But here I want only the good two classes. I want to just classify into two, whether it is good or bad. So almost done. Okay. Now it is ready. It is already trained. Okay. It's trying to take my picture and tell me. Hilarious. Okay. So I'm going to now use file, and from the file I will choose the image. So I'm going to take a test image. Okay. So I have some testing data. I'll take some image, any random image from this, and I will give. I took a image of a good tire. See, the output is 100% accuracy. You can see here, 100% it is saying it's a good tire, not even 99%. Again, I will take the image of some other tire, and let me see, this is also good tire. So again, it is 100% accuracy. Okay, I'm now going to take the image of some bad tires. I have testing data. This testing data is not the same which I have uploaded there. So I'm not using the same data which I have uploaded. I have had a separate data. So I will take some data which is cracked. Okay, and I'm going to take it. Now you see here, 100% it is, see, it's telling it's a bad. Again, I'll take some more data from here. That, see, the image is not, all the images are different. Okay, fine. It has gone to some other site. Give me a few seconds. Okay, fine. You can see that 100% accuracy, it is saying it is bad. So this is how, student, the practical example of how computer vision work. Okay. So I'll give you some more example now before I wind up the session. Some, example of industry. Okay, now you can see here. So these are certain tools which you can use. I use some tools I have shown you. You can use all these tools which are free. NLP Architect, LNLP, Spacey. Okay, some example. You can see how NLP is used here. With computer vision, it's the driverless car, how it is trying to identify the object. So as I said, that computer vision is a technique that abstract the information from visual data I just showed you, from images and video. The computer vision works similarly to human eyes with brain work. How do we see and interpret? So similar thing the computer vision does. The visual data, images, videos are, interpreted, and it find the meaning out of it. So there's a lot of visual data, which is label data. If it is trained or if it is fed to machine, the machine get trained. I just showed you some example of that. Okay. So what are the field in which computer visions are used? Object classification is used to classify image, whether as I said, the car can identify whether the image is a dog or it's it's a cow or it's an obstacle or it's a barricade. It can take the clue from the video also and classify the object within the video. It can detect any object uh, of anything which is there. It can detect a landmark. It can use for search criteria. So many things it can do that. Okay. So this is the work of the computer vision. So whatever it is, if you place like this, how it can identify and classify between dog, cat, but you have to then feed the computer with those kinds of things. The application of computer vision we can see in facial recognition system. The computer vision can detect the face image of the people to verify their identity. So social media platform, Facebook and even Instagram is now using the facial recognition system to identify and tag a person in a particular group photo. Healthcare and medical industry computer visions are used basically to evaluate certain kinds of or diagnose certain kinds of cancer tumor. uh, from there it is for doing a prediction also. Self-driving car, I told you, like Tesla or Google car, all these are using the um, computer vision to sense around the surrounding, capture the images and the video from the camera or from the lidar, and the software help in determining whether there is an object or traffic signal or a pedestrian walking or a dog or a cat or something like that. Optical character recognition is using the nowadays using the you're called the computer vision to basically read and extract text from documents like invoice, bill, article. Machine inspection, computer vision is used in factories for doing a image based automatic inspection. It find out a defect in a machine by just taking a picture and analyzing how it is working. In retail industry, computer vision is used to track product, shelf, wages, record movement into the store. So AI based computer vision technique is automatically charge the customers for any product which is marked and checked out, like Amazon Pay and Go. Then 3D model building, retail stores are using, real estates are using to make a 3D model. Even the car companies are making use of 3D model where it can make the object on the surface and you can just imagine it. I was watching that movie of Alia Bhatt and I saw that 3D mapping. Medical imaging companies are using the computer vision by the medical professional basically to treat the patient by developing the visualization of specific body part, organs, and tissues. It helped them to get more accurate diagnosis and better patient care. So you have CT scans, right? You have MRI scan, which is used by pathologists that can be feeded into computer system to analyze. Automobile safety, computer visions are adding safety features now in all, not only in the premium car, but also Maruti is also using that in order to sense certain kind of accident and prevent certain kind of accident, I'm sorry, and detect certain objects and give you like sensors are added and even the cameras are also there basically to help you in giving you guidance on that. So certain companies are using that. For surveillance, CCTV cameras. Nowadays in Bangalore, they're installing a lot of CCTV camera with facial recognition system to identify certain spots, certain things which are doubtful, which are suspicious activities, suspicious behavior to prevent crime. Fingerprint recognition. So this is the camera even in the Bangalore, you might see in MG Road, they're installing it now. Then the fingerprint recognition biometric system, trying to identify the psychological characters of your face, finger, vascular, iris scan, and all these are using the computer vision nowadays. Okay. So let us see some example of these. Okay, I'll just pass on this. I'll show you some example, some videos.
In autonomous vehicle software, deep neural networks are often trained to detect an object using a bounding box around the object. Today in Drive Labs, we're going to talk about using a DNN to provide pixel-level accurate object shape information. This is known as panoptic segmentation. In the top video, we see pixel-level shape segmentation results for different object classes, with vehicles in blue, pedestrians in red, and drivable space in green. And in the bottom video, we see segmentation of these object classes into individual instances as shown by their unique object IDs. So each of the pedestrians at this intersection is detected and tracked as a different instance. We detect object shape details, including the rear view mirror on the bus coming towards us, unusually shaped trucks, and the precise shape of a trailer. And despite occlusion by the tree, this car is still detected as a single instance. And here we see accurate segmentation of drivable space around traffic cones and on-road traffic signs. In this clip, the panoptic segmentation DNN is segmenting both cars and drivable space accurately in an unstructured environment. Panoptic segmentation of objects and free space provides a deeper and richer understanding of complex scenes, such as dense traffic with vehicles occluding each other, or construction zones with unusual object shapes, or corner cases, such as pedestrians carrying large objects.
Okay. So,
In autonomous vehicle.
So we'll see in manufacturing how computer vision is used. You can see that how it detects in car manufacturing. It does all quality kind of checking that every screw, every part is there in the place. And so all quality control, all everything is done with the help of now computer vision in the manufacturing industry. I'll also show you the example of, okay, we'll see the example of BMW, how they uses the computer vision to detect car model in assembly line. We'll see one more example.
Imagine looking in your rearview mirror and seeing this 70,000-pound 18-wheeler behind you without anyone at the wheel. Well, we are pretty much there because this truck is driving itself. Aurora Innovation already has autonomous trucks like this one cruising the highway, just with a babysitter at the wheel.
At Aurora, we're building self-driving technology.
Sensors track what's going on around the truck, and an onboard computer not only drives, it does so as politely as possible so it won't freak out anyone else on the road.
It's a combination of hardware, software, and data services that allows us essentially operate vehicles autonomously.
These trucks all share a common robot brain, and that brain has driven 5 million real-world miles. Every time one truck drives, they all get smarter.
So it really understands.
And I'll show you also.
Imagine looking in your rearview mirror and.
So road traffic analyzer, let me show you that. It's in Germany city. German city.
The city of Darmstadt near Frankfurt in Germany doesn't escape the problems of traffic congestion. In order to make intelligent traffic management possible and make traffic flows smoother, The city's traffic authorities make use of video detection and management technology from FLIR systems.
Durch die unterschiedlichen Einsatzfelder der Videodetektoren haben wir festgestellt, dass sie sich sehr gut eignen für eine verkehrsabhängige Steuerung. Wir konnten die Qualität der verkehrsabhängigen Steuerung im Vergleich zum Einsatz von Induktionsschleifen deutlich verbessern.
Also der große Vorteil der Videodetektion im Vergleich zu Induktionsschleifen ist, dass wir keinen Tiefbau benötigen, keine Fremdfirmen extra beauftragen müssen, die uns die Schleifen in die Fahrbahn legen, sondern wir montieren einfach die Kamera dahin, wo wir sie hinhaben wollen, verdrahten sie und tun sie anschließend konfigurieren und fertig. Mit den Videodetektoren sind wir auch in der Lage, eine Stauerkennung durchzuführen, um bei erhöhtem Verkehrsfluss eine Grünzeitverlängerung durchzuführen, um den Stau und beziehungsweise den erhöhten Verkehr abfließen zu lassen.
The city of Darmstadt is using various types of video sensors for vehicle, pedestrian and bike detection. This has made the inner city traffic a lot safer and more efficient.
Wir befinden uns hier gerade im Ortsteil Darmstadt-Dessung. An der Verkehrssignalanlage grenzen 2 Schulen an. Und hier ist es relativ gefährlich, wenn die Schule aus ist. Kommen ziemlich viele Schüler beisammen. Um die Sicherheit der Schüler und der Passanten hier zu gewährleisten, dass sie vernünftig bei Grün über die Ampel gehen können, haben wir Kontakt zur Firma FLIR aufgenommen, haben sie geeignetes Produkt gebeten. Und somit haben wir hier im Hintergrund die Seawalk installiert. Diese detektiert eine Masse an Leuten und passt dementsprechend die Grünphase der Verkehrssignalanlage an, sodass gewährleistet ist, dass auch der letzte Passant, der gerade über die Straße geht, sicher über die Straße kommt. Und parallel zu Seawalk haben wir noch normale Traffic Cams angebracht, die den...
Okay, students. So I have a meeting. I'm so sorry. I have to go now. So I'm going to stop the session here. Thank you. See you next week.
Thank you, ma'am.
Thank you, ma'am.